A parallel plate capacitor of plate area A, each and separation D is being charged by an AC source. Show that the displacement current inside the capacitor is the same as the current charging the capacitor. Let me see the circuit diagram here. This is the capacitor and is the voltage, that is V is equal to V naught sine omega t. Okay. And we know that when the capacitor is getting charged, we have the electric flux. That electric flux is equal to 5 times E into T. And we can also write this one as Q times of T divided by epsilon naught. And then we can find the QT, Q times of T is equal to CV times of T, where V is equal to V naught sine omega T. If you are going to substitute here, we get C into V naught sine omega T, sine of omega T. And therefore, the displacement current, displacement current, it is denoted as ID. I is the symbol for current and D is the displacement current, which is equal to epsilon naught times D phi E divided by with respect to dt, then epsilon naught, which is equal to epsilon naught 1 by epsilon naught into d by dt into C V naught sine omega t. Then we can write this one as, it is get cancelled, then it comes omega into C V naught cos omega t, cos of omega t. Okay, then if I want to expand this one as omega times C V naught sine of omega t plus pi by 2. Okay, and also the conduction current, displacement current we noted as ID and the conduction current we noted as IC, which is equal to V naught divided by 1 by omega times C sine of omega t plus pi by 2. Okay, which is equal to omega into C V naught sine of omega t. Then we can write as both are same, ID is equal to IC. It is the displacement current is equal to the conduction current.